female speakers to telecom events. Thank you for doing, and I'm going to give to every woman that attends here. I'm starting with you.
Thank you.
Because even in attendance, we don't have so many, and a small appreciation for your initiative to come here, and Yufei we have here. Hopefully I counted right how many I need to bring. And is any other woman in the room at this moment? Sorry? Yeah, I will give it when I'm at her. Okay, let's start. We started a bit late, so don't stress about that, but people wanted to have the coffee. Elena, again, thank you for coming. Push notification in a scalable way with calling and so on. Very much appreciated for taking your time, resources to come and share with us. The floor is yours.
Thank you. Hi, everyone. So this is my first time here at Kamailio World as a speaker, and it's really a pleasure to be here. I'm Elena, and I'm from Spain. I started working in voice over IP systems, understanding the SIP protocol more than 10 years ago. And now I'm working at CloudTalk as a senior voice engineer. CloudTalk is a cloud-based contact center platform, and well, I put some numbers here about our infra. So we are managing 15,000 registered users every day and around 2,000 concurrent calls in a distributed and decentralized architecture around the world. So today, I'm going to talk about push notifications and WebSocket connections, and then how we are scaling Kamailio instances in AWS. So we are managing in our infrastructure auto-scaling groups and Kamailio instances behind a load balancer. Then I'm going to talk about use case in production about the network switching, and just to finish the presentation, well, I'm going to talk about a little bit about voice agents, because you know it's a trending topic now. Okay, so push notifications. Whatever is the reason, mobile devices go inactive. So doesn't matter if we are killing the application, the mobile is going to a standby, or just suspending the mobile. So mobile devices go inactive. It means that the mobile device is breaking the WebSocket connection. This is something that anyone building a SIP client application knows. So what is the process here? We have in our phone the application running with our SIP user agent, sends the register, and we are creating the WebSocket. But then if the mobile goes to a standby, and Kamailio would like to send the call to the phone, doesn't matter if we have the ping-pong messages, keep alive, and so on. And doesn't matter if Kamailio has in the location database, in the location table, the information about the public IP of the phone. Kamailio cannot send the invite, cannot send the call to the phone, because the WebSocket was broken. And of course, this is the reason, one of the main reasons that push notification exists. So as all of you already know, we need to send a push notification to the phone, so the phone wakes up and then creates the WebSocket connection, and we can send the invite. How we are doing this one? Well, we have here a simple diagram. So Kamailio is receiving the call, the invite. Kamailio is going to send an assigned HTTP request to the application. The application wakes up, send the register, create a new WebSocket connection, and then Kamailio can continue sending the invite as a regular flow. The thing here is that Kamailio needs to wait until receive the register. So this is the thing. We are doing this using two functions of the TMX module, T-suspend function and T-continue function. So here we have a little piece of code. Kamailio is sending an HTTP async request to a push notification service. So the push notification service sends the push notification to the app, wakes up the mobile, the application, and then Kamailio is suspending the transaction. It means that Kamailio is saving in the shared memory all the information about the transaction with a timeout, of course, because if you never recover the transaction, it will not be pending there for minutes and hours. So Kamailio is saving everything, is saving pseudo variables, everything in the shared memory until waiting a trigger to continue the transaction. So our trigger will be the register. So when we are receiving the register related to the same user, the same call, we are continuing the transaction. It means that in our request route, we have the register process with the pseudo variables and so on related to the register packet. And then when we invoke the tContinue, Kamailio get in the main request route everything related to this transaction, so you can continue working with the invite as in the first line of this code. But then, well, we wanted to complicate our lives, adding redundancy, scalability, high availability, and so on in AWS environment. So we decided to go with Kamailio instances inside an auto-scaling group. It means that we have a load balancer which randomly is sending the requests to any of the Kamailios in the group. So here we can see our auto-scaling group, Kamailio 1, Kamailio 2, Kamailio 3, and so on, and the load balancer. Well, in AWS, we have three types of load balancer. So we have the network load balancer. The important ones are two: the network load balancer and the application load balancer. But in any case, anyway, these types of load balancer doesn't know nothing about SIP. They are not deciding, checking SIP headers or whatever. So the invite is coming to the load balancer, and the load balancer is sending the invite to Kamailio 1. So similar as we saw before, Kamailio 1 is sending the push notification request. The push notification is going to the phone, and the phone sends the register to create the new WebSocket. The new WebSocket is created with the load balancer, and the load balancer gets a random Kamailio. In this picture, it is Kamailio 3. So, well, we have here a cool deployment with Redis shared between Kamailios and so on. So, okay, maybe we can try to send the invite from Kamailio 1 to the load balancer, because we can use the WebSocket here between the load balancer and the phone. And, well, of course, we are seeing here the solution that we can't, because the load balancer will drop this packet. The load balancer cannot establish the same WebSocket connection with the same source IP, source port, destination IP, and destination port to link this WebSocket connection to two different instances inside the cluster. So the load balancer will drop our invite here if it is coming from Kamailio 1. And well, in addition, I didn't add here more things to not overcomplicate, but AWS has a lot of possibilities to try to send packets to internet. So AWS will use the NAT gateway to send the invite to the phone. But again, the NAT gateway cannot create a new WebSocket to the phone. So, well, this is the architecture that we have and how we solved this issue. Well, before going to the solution, so we don't want to have isolated regions. We want to have a group of auto-scaling groups in each region, and each auto-scaling group has its own load balancer. So if we have a company in US receiving calls from US, but agents, some agents, of all agents, doesn't matter, are distributed around the world, we would like that the call from US goes to Europe, for example. So we don't want to isolate regions, and we want to make the solution possible between regions too. Of course, with some delay, but it's okay in this case. Just the SIP protocol is so fast. Okay, so here we have a similar diagram explaining the solution. The first part, it's similar. Well, the first part is the same. So Kamailio 1 is receiving the invite, sending the async HTTP request on external service to send the push notification, and suspending the transaction. But then, as we saw in the diagram before, the register is going to Kamailio 2 in this image. So we are adding a parameter, an encoded cookie, indicating in the push notification that, hey, Kamailio 1 is the instance which has the invite suspended. So then, in the register, we can see that we are sending the instance ID in a zip header. So when Kamailio 2 receives the register, send an internal request message, in this case, to Kamailio 1, indicating like, hey, I am Kamailio 2, and I am the owner of the WebSocket connection. So then Kamailio 1 can search in the location table, but we have some delays between regions in database. So in this case, Kamailio 1 just needs to send the invite to the source IP of the message, and then Kamailio 2 will follow the regular flow to send the invite to the application. And here we have, again, the simple code used to do this approach. It's similar to the previous one. Well, here we are managing the message. So if we receive the message, we are going to continue the transaction. Well, I didn't mention before that the T-suspend and the T-continue transactions, you need to save the indexes to identify the transaction, of course, which again is in the shared Redis in the cluster. So again, we continue the transaction, and then we are going to manage. When we receive the message, continue the transaction because the message is the trigger, as we saw. So here we are going to decide if the message is coming from my IP, means that I am the Kamailio with the WebSocket connection. So just send the location, the invite. I will follow the usual flow. And if not, it's very easy too. So we are just changing the destination URI, use the T-relay to send the invite to the proper Kamailio instance. As all instances in the cluster, of course, has the same configuration. And now I'm going to talk about network switching, which is an issue that we have in production or had, and it's not a bug, it's a feature. Well, network switching is happening when the mobile change the network from the cellular to Wi-Fi or vice versa. So we have two cases of network switching. The first one in the left side, network switching during an active call. So what it means, and of course I am talking about the mobile devices and applications, it's like the same topic. So we establish the call with the flows that we already saw and so on. And then the mobile switch to the Wi-Fi or switch off the Wi-Fi or vice versa. Yeah, so the mobile, here the application needs to do things, of course. So the mobile is going to send a reinvite because the mobile needs to restart ICE, get the new candidates, and so on. So it's sending a reinvite to negotiate the new IPs and the new media parameters, of course. And well, if our Kamailios in the cluster, in the autoscaling group, are sharing the dialogue, this is working as it is because the dialog is already established. We are not talking about the first invite or the first ACK. We are talking about a reinvite during a dialog already established. So that's it, it's working. But now I'm going to talk about a tricky case, which is the network switching during ringing. And why? Because we can think that it is a corner case, but it's not a corner case for us, maybe for others too. So if your mobile device is in a standby, like more than 2 hours, or something like that, sometimes iOS and Android, okay? The mobile is switching off the Wi-Fi, but switch on the Wi-Fi just when the mobile is receiving the push notification. So we have here a really tricky case because, well, in the first part of the diagram, we see that Kamailio 2 is sending the push notification, the mobile wakes up with the cellular public IP, send the register, create the WebSocket, and the invite is sent to the cellular public IP. But then after 1 second, or I don't know, some milliseconds, 2 seconds, the mobile switches on the Wi-Fi. So, well, the mobile application needs to do a lot of things here. It's not just sending the 200 OK. Needs to restart the ICE, get the new candidates, send a register, and establish the new WebSocket connection. But finally, it's sending the 200 OK. So, well, for us, it's breaking the path. Well, first of all, the application can detect this network switching. So the application is sending a specific header in the 200 OK telling us like, hey, the network switching during ring gear happened. Well, so Kamailio 3 receives the 200 OK and magically, it's working for 200 OK its path because, so all Kamailios in the cluster has the same configuration. Of course, each Kamailio has its own private IP, but all of them are setting the same public domain of the load balancer in the advertised parameter. It means that in the last hop in the Kamailio 2, the via added in the invite includes the domain of the load balancer, not the private IP of the Kamailio 2. So when the 200 OK arrives to Kamailio 3, Kamailio 3 see the domain of the load balancer, which is in its own configuration in the advertised parameter, and that's it. OK, the 200 OK is for me too. And then Kamailio 3, well, will remove the via and so on, and the 200 OK path is done in a good way. But the ACK, no. So because here in the 200 OK, of course, the application is sending the same record root headers that received in the first invite. So the ACK follow the first path, which is Kamailio 1, Kamailio 2. But then Kamailio 2 would like to send the ACK directly to the application, but it doesn't have the WebSocket connection again. Well, to solve this issue, personally, I tried first modifying the 200 OK record root headers in the Kamailio 3. You can change the IPs, but you cannot change everything. You cannot change the identifiers of the record root. Well, and honestly, it is a little bit dirty solution. So, well, you just need to send the ACK to the instance that you want, and that's it. So Kamailio 3 is receiving the 200 OK with the specific header, got it from the application, and it's saving in the Redis the Kamailio 3 IP. So in Kamailio 2, when Kamailio 2 is receiving the ACK, we are going to check in loose root function before the loose root and after the loose root function. So after the loose root function, Kamailio 2, the zip process, we will not have any record root headers because it's the last hop. So we are detecting this and sending the ACK to the Kamailio 3. And Kamailio 3 is receiving the ACK without any record root headers. So it's our ACK, it's our use case. So Kamailio 3 can send the ACK to the application and establishing the dialog. Well, and then to finish the presentation, I don't want to talk about a different topic. I'm going to talk about this because just to highlight that we used the same solution, the same approach, and the same architecture to work and deploy voice agents. So more than 1 year and a half ago, we needed to develop so fast a voice agent solution. We didn't have time to create a full SIP server from scratch to manage this thing and so on. So we are creating voice agents on demand using exactly the same code. So Kamailio 1, again, is sending an HTTP request. Well, it's not push notification. It's just the HTTP request to the streaming service, in this case, API. And this streaming service is creating the voice agent, sending the register, receiving the invite, and propagating the streaming to the AI. So, well, that's it. Thanks to all of you. Questions are welcome.
Thank you, Elena. We have time for questions. We have Ihor. Thank you.
Yeah, thank you. Very interesting. I have a question. How, in this tricky case, when you have switching in the mid-dialog, how do you deal with the dialog states on Kamailio if you do? Like, because you have sort of hanging dialogues and there is a mid-dialog in Kamailio 3 or something like this.
Yes. So in general, in our auto-scaling group, we are sharing the dialog using Redis. So it's a really good question because Kamailio 2 is never receiving the 200 OK. So from the point of view of Kamailio 2, the transaction dies. But the transaction dies there, and that's it. It's not propagating any issue to Kamailio 1 or Kamailio 3. So the transaction dies there, but it doesn't matter. We can continue with the call flow.
Dies silently.
Yes, yes. And then if we need to put on hold and retrieve the on hold in the application, we always are going to follow the second path. So, yeah.
Okay. Stefan here.
Hello. Do you use Topos in your Kamailio cluster?
No.
Okay. Thank you.
So Topos is topology stripping, making it to look like back-to-back user agent, more or less. I guess Stefan there contributed some code there. I'm wrong or not? Hash table came from you? Topos hash table? I remember. We have Andreas here.
Thank you very much for the presentation. There's quite some complex routing in place, and things go wrong sometimes, right? How do we approach troubleshooting? Because you have like 3 different Kamailios, very complex call flows, and if you're trying to stitch together the actual path, how do we approach this in terms of following the call flow and how it really went through all the instances then?
For the first, here, this one is the most common one scenario using 2 Kamailios. Well, we are sending a specific header, and we are managing a dialog variable and a specific header indicating, hey, I am the Kamailio 1 in the path, or I am the Kamailio 2 in the path. This is the way that we are distinguish Kamailios in the same code. Nothing special.
Okay, one last quick question here from Dragos, not to delay too much.
Thank you for the pressure, Daniel. Since we are on this slide, I see there X header instance ID. I think there is an RFC 8599 which standardizes these things with contact. I don't know if you consider that or you think that's bad? I don't know.
But are you talking about the header, the identification, or what?
So that RFC specify exactly this service. How do you push notifications to some mobile phone with contact parameters, so you could suspend things and then resume? It seems very much what you're doing.
So, okay, here Kamailio, when it's sending the push notification, it is just an HTTP request to an external service. This external service is managing the push notification properly. And we are sending more parameters, like the user. So the all data that the application needs to show things properly and so on. So yeah, we are sending the user. Sometimes the type of call, if it's incoming, outgoing. Well, yeah,
Okay.
It's external service managing it. And here, of course, I talked about the happy path. So, of course, the push notification can be rejected. So we have solutions for, if the push notification is rejected, we are canceling the call. If the user, if the application is never registered for some reason, or we are not sending the invite, we are sending messages to application to have everything synchronized.
Okay, I see it's very popular to ask questions, and unfortunately we can't really get more because we get delay, but we have the breaks and lunch breaks and try to approach the speaker for clarifying or getting more details. Sorry from there, I can't. So now we'll invite the next speaker. Thank you, Elena.
Thank you.
Very interesting, very appreciated. From